The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
Okay, now let's talk about kinetic control versus thermodynamic control of our reaction. Any reaction can take more than one pathway to give more than one product. For example, let's just say our starting materials here can give us a kinetic product and a thermodynamic product. The kinetic product is always going to be the faster one, and it's the one with a lower activation energy. Now let's talk about how the temperature will actually impact the different products that are formed. If our temperature is high enough to get over the first activation barrier here, EA1 that we see, then we will have kinetic product formation. Now that we're here, these products, they will not have enough energy to get back over the reverse activation energy. We will have kinetic product. Okay, great. Now let's talk about what would happen if we increase the temperature even more. Say we increase the temperature enough to get over our second activation barrier here and high enough to get over the reverse activation barrier for the kinetic product. We will see kinetic product formation and we will see thermodynamic product formation. However, the kinetic product has enough energy to come back over this hill, right? And then it will react to give the more stable thermodynamic product. Okay, great. Now say we raise the temperature even more. Say we raise the temperature enough to, we'll just call this here the reverse activation energy for the thermodynamic product. If we increase the temperature enough now to get back over the reverse thermodynamic product and high enough to get back over the kinetic product, then our major product will be the thermodynamic product that we see here, right? And the ratio of thermodynamic product to kinetic product can be found through the respective equilibrium constants for the thermodynamic and kinetic products. Okay, great. Now let's move on to our next slide. Let's take a look at catalysts. Let's begin here with a definition. Catalyst, a substance which speeds up the rate of the reaction and it's not consumed in the reaction. We see here we have, and how does the catalyst speed up the rate of the reaction? Well, it lowers the activation energy as we see here, right? This is lower than this one. Okay, great. One other point, in contrasting a catalyzed and an uncatalyzed reaction, just know that the energy of the reactants and the energy of the products does not change. Okay, great. One other definition that you should be familiar with is catalysis, and that is the increase in reaction rate which results from adding a catalyst. And in a few slides, we'll take a look at enzyme catalysis. Okay, wonderful. Our first type of catalyst that we'll look at here is a homogeneous catalyst.